So today I want to talk about this study. And this study was a failed study. And it was about expedient techniques to strengthen floor joists so that homes could withstand a higher shock load from overpressure from a nuclear detonation. The thing is, this failed study provides us critical information on mistakes. So when we read through this and we look at some of the reinforcing methods were actually valid. The problem was the fasteners and the lack of construction cement, construction glue to glue the stuff together. So before we look at this, what I want to tell you is in the conclusion of this study, what they found was regular nails would pull out. So what I want to tell you is regular nails pulled out during this study when subjected to high PSI overpressures. And the problem is when you reinforce floor joists and floor systems, you don't want individual pieces of that system acting independently, and that's where the problem arose. What you want to do is use glue, ring shank nails, twist nails, glue nails, or screws or bolts so that everything flexes together and distributes the load. So the failure mechanism here was that there wasn't sufficient strength of fasteners in the regular nails, so these units did not act as one body. They acted as individual pieces. That's what led to failure. So this is actually a critical study because it shows you what went wrong and how to fix it. So what we have is typical floor units with floor joists, a underlayment, and plywood on top. And what we're going to do is do several different things to reinforce this. So here you can see we're using metal strapping. In other panels, you'll see what they did is they put plywood underneath of the floor system from the basement side and fastened it. And we also see that they use different iron strapping and bar stock. We'll take a look at that in the photos. So here we have iron strapping that was nailed in. And you can see the joist has failed anyway under the high PSI overpressure. This is an example of unreinforced floor that failed. So this was the control sample. So this is an example of the iron bar or bands failing. They were put on the bottom side of the floor joist and fastened with nails. Then we come over here and we have a composite where we use the strap on the bottom of the joist, and we also use strapping around the joist. This failed also, but you can see that progressively the failure here was less with the reinforcement than it was with the control sample. This is another view of the strapping both on the bottom of the joist and around it. This is more detail of the strapping and the failure points. Now what's interesting here is this was an example of the failure zones that were found on the steel reinforcement straps. So you can see the hashed area where there was actually failures in the joists. But when we look up here to the banding that actually goes around the joists, you'll notice the failure areas were actually much smaller. So that's something to keep in mind. Now, one thing I want you to keep in mind, on some of these tests, they covered the strapping with a sheet of plywood. They only used 1/4-inch plywood on the bottom of the joists. This also pulled out. When we look at these methods, the methods are valid. But what we need to do is use a construction adhesive like liquid nails and glue everything together, and use ring shank nails, twist nails, glue nails, or screws. That way we reduce the likelihood of pullout. So please comment, share your thoughts. We'll see you on the next video.